Okay, good morning then, Frogmore. This lesson's for the Year 9 classes I'm setting work for, but actually could be used for any class in the school. Okay, so it's sequences and nth term. We're going to be having a look, hopefully, at all of it, all in one today. So next term of the sequence, term-to-term rules, which a lot of people get confused with the nth term, so let's be careful with that. Term-to-term rules. Nth term, some basic and some negative as well. Some generating sequences from the nth term, so that's when you're given the nth term and they want the sequence, whereas this one's more looking at when they give you the sequence, what's the nth term. And then some other sequences that you need to be aware of for your preparation for GCSE. Okay, so the first one, the next term. All we're doing here is we're literally thinking, how do we get from here to here? And so on. So quite nicely here, plus 3, plus 3, plus 3. And that means the next one must be plus 3, so the next term is 17. Nice and easy. Again, quite a simple one. We're just looking at this. How do you get from this to the next? Take 2, take 2, take 2, take 2. So we're left with 2. The next one, straight away you're looking at it, you might be thinking, oh, add 5, and then, oh, hang on. And this is why you should check it. Make sure you think, hang on, that's not add 5, that's add 10. Okay. Now, this could be one of two things. Actually, they take both answers if you did this. You might think, oh, there's a pattern here, add 5, add 10, then add 15. That would be 35. That would get you the mark in this example. Or you might think, hang on, it's doubling. Now, obviously, double 20 is not 35, it's 40. You would also get a mark for that in that example. Now, I've seen those sort of things in a GCSE and they will take both. However, you're more likely now to get something along this line where you've got that extra one, so it's showing, right, it can't be add 5, add 10. It's got to be the doubling each time. Okay, so in that case, this one would be, of course, 80 after that. Right, so the second one, term-to-term rules. Now, a lot of people will look at this straight away and go, oh, I'm going to find the nth term. Don't do that. This is not the nth term. When it talks about term-to-term rules, it just literally means, how do I get from there to there? Add 3, add 3, add 3. So the term-to-term rule is add 3. To get from one term, this is a term, to the next term, you add 3. Okay, the next one, add 6, add 12, add 24. Okay, so that's going a bit wrong. And look, here we go. That's because this is multiply. I'll talk to you about this in a bit, but this is called, the fancy word for this is a geometric sequence. However, the answer is just multiplied by 2. Okay, it's just a term-to-term rules. It's nothing fancier than that. Now we're getting into the nitty-gritty, the nth term. So we have a look at what's going on. Just like we've been doing so far, we start with just writing down the term-to-term rule, the difference between here and here. How do you get from there to the next one? Because this is constant, I want you to start thinking about a times table that goes up in 3s. There's only one times table in the world that goes up in 3s, and that's 3 times table, and we're going to write that in code 3n. Okay, because it's to do with nth term. So instead of writing 3 times table, which we know it's going to be to do with, we write 3n. So whatever this goes up in, that's what we write next to n. We're then going to write our 3 times table just above it. 3, 6, 9, 12. Now, if that was exactly identical to what we want, that would be answer. Boom, done. It's not though, we've got to do something. So this is our 3 times table here, but this is what we actually want. We want this. So what are we going to do to our 3 times table to get to this? Well, all of these numbers, you're just going to be adding 5 to get down there. So you just do 3m plus 5. The next one, going up in 5. So that's it done, by the way. That was the answer. Up in 5s. So we know that's our 5 times table. So we write our 5 times table above, 5, 10, 15, 20. and it's not identical. And what do we actually have to do to get to what we want? We have to take 3. Okay, now if you're getting muddled with whether you add 3 or take 3, have a look at both of these again. And can you see the difference? This one we've got the 3 times 2, we're having to add to it. This one we've got the 5 times 2, and we're having to take away to get to what we want. So that's why this is take away, whereas that one was add. Okay, that's done. This one, add 6, add 6, add 6. So it's a 6 times table. You write your 6 times table. And what do you know? As if this was planned already, these are identical. Some people then attempt to write +0. It's not going to, be the end of the world if you do that. But that is the perfect answer. 6n. Right, next one. Nth term with negatives. So this isn't going up, this is going down. This is take away 3 each time. Now, there is no times table that goes down in 3s, but if there was, it would be called the -3 times table. We're going to write our -3 times table above, which is almost identical to our 3 times table, apart from it's got a minus in front of all of them, of course. We then think, how do I get from here to here? -3 all the way up to 94. Well, -3, get yourself to 0 first, add 3. Then to the 94, so add another 94. So that's add 97 in total. And you should find that all of these are the same. Do check it. Okay, do check as you go through so you're not just, always assuming it will be, because it won't be, especially when it's to a point where you go on to quadratic nth term in the future. So be prepared for that. So by double checking as you go through that is add 97. And that's that one. So the very last, two more generating sequences. So if I want the first term, second term, third term, fourth term, fifth term, sometimes I say to you, write the first 5 terms. I'm just going to do 3, and instead of that n, and 3n means 3 times n, instead of that n, I'm going to write, for the first one, 1. Because for the first thing, n equals 1. 3 times 1, 3. For the second one, I'm going to substitute in n equals 2. N equals 2 into here, 3 times 2, 6. N equals 3. N equals 4, and so on. So whatever one you're after, you just substitute that in. Now, there is arguably a quicker way. You could just write that as your 3 times table, boom, done. And for this one, just add 1 to all of those. But when it gets onto 50th term, 100th term, 2000th term, then it gets really tricky. You're not going to be wanting to write 2000 numbers. So do it this way. You just substitute in n equals 1 into here. 3 times n is 3 plus the 1, 4. 3 times 2 plus the 1, 7. 3 times 3 plus 1. 3 times 4 plus 1. 3 times 5 plus 1. 5n minus 2 is just 5 times 1. 5 take 2, 3. 5 times 2 is 10, take 2, 8. 5 times 3, take 2, 13. 5 times 4, take 2, 18. 5 times 5, take 2. And this is why, because if you want the 50th term, you're not going to want to keep going all the way to 50 terms. So we're just going to do 5 times 50, that becomes 5 times 50 is 250. Take away the 2 is 248. So that is the 50th term of 5n minus 2. And now the last one, geometric. Okay, geometric, this is just talking about different sequences. Geometric always multiplies by something. Okay, arguably or divides, because dividing by 2 each time is the same as times it by half. But I'll give you an example of a geometric. Let's start with 4 and multiplied by 3 and multiplied by 3 and multiplied by 3, and you keep going like that. And that's your geometric sequence. Okay, Fibonacci type. The actual Fibonacci starts with 1 and 1. That's the Fibonacci sequence. And then you add these 2 numbers together to get this one, and then you add these 2 numbers together. So you always add the 2 previous numbers, not all of them, just the 2 before, to get the next one. And keep going like that. Okay. Now Fibonacci type means you can start with any numbers you like. So let's go with 2 and 8. Okay, so this isn't carrying on from here. This is just a completely fresh, new Fibonacci type sequence where you add those 2 numbers together, then add those 2 together, then add those 2 together, then add those 2 together, and so on. Okay, stop there before I make a mistake. Triangle numbers start with 1, You then add 2. You then add 3. You then add 4. Let's make that a bit clearer. You then add 5. And they make a sort of like, there's the first one's just there, 1. The next one's all 3. Then 6. Then 10. That's why people make it look like a triangle for you. It looks almost like, when you go bowling, how they'd set all the pins up. And then you add 5 and so on. Square numbers, I think you know. 1 times 1, 1. 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. Do you know any more? Okay. There are quite a few, some basic ones, odd numbers, even numbers. Of course, with square numbers, I think you probably guess what the next one to look at would be. But that's everything you need for the sequences test. Good luck.